Hello students, welcome to the session combinations under prerequisite to probability. So under prerequisite, already we have discussed two sessions, two topics. One is the set theory, other one is permutations, right? So just now finally we just will go for combinations, right? So with these three prerequisites of set theory, permutations, combinations, so we can enter into the main concept of probability, right? So first, let us discuss about combinations. Okay. So suppose we're having n objects. So here, just observe the definition first. So n objects are a day, right? Right. So I have n objects, right? And from these n objects, I have to select r objects. Okay. So that selection is nothing but it is called combinations, right? It is a combination of n objects taken r at a time. A big line. Combination of n objects taken r at a time, or simply we can say it is a r combination. So simply we can say it is a r combination, right? So that the two ways we can simply say. So it is one is this is a r combination, right? So r combination. So what is that? It is simply a subset of r elements. Okay, a subset of r elements. So we can simply say selection of r objects from n objects, selection of r objects from n objects. Okay, so in other words, we can also say that a subset of r elements, subset of r elements, right? So that is what we call as r combinations. For example, you have four elements here. So a, b, c, d, four objects are four elements, and then now we have to take three elements from four. So a subset of three elements we can say, a subset of three elements from these four elements we can say, or otherwise we can say a selection of three elements. Okay, subset of three elements or selection of three elements from four. So what are the possible ways I can select three? So ABC, ABD, ACD, and BCD. So these are the four possible ways I can select three, right? ABC, ABD, right? And ACD, and last one is BCD, right? These are the four ways I can select, right? Or simply we can also say like this, ABC, no need of, as a theory, if you say subset point of view, we can put them in the proper brackets like this, or otherwise simply we can represent like this, right? These are the, these, right? So remember here, when I say ABC, you may have the doubt, sir, what about ABC is okay, but what about ACB, BAC, right? So we don't take, when I say selection means three elements are taken A, B, C, but which order we are following is not important. See, for example, coming here, ABC, ACB, BAC, BAC. So we don't consider all these things. When I select the three means ABC, it's enough. I need not to say ACB, BAC, like, so I have to neglect all these. We need not to take all these things. It is enough if we say ABC. But when we consider all these, it is the case of arrangements. When it is the case of arrangements, suppose if we say what are the possible arrangements ABC, say I can say ABC, ACB, BAC. These are all arrangements. When I say selection point of view, it is enough if I take ABC. So these are all not necessary to take. Not necessary means that both are all are same. All are same. Okay, that is one thing, right? So simply we write A, B, C, right? And in this point of view only, let me discuss about the difference between combinations, because now you got the combination as well as permutation. So I have say I am taking the n objects as usual. So now what is the meaning of the first one? R, sorry. So R permutations. Okay, this is already I discussed R permutations, and now just now I'm discussing about R combinations. So generally, what is the difference between combinations and permutations? So here it is always the word we use, arrangements. Okay, so whenever I say arrangements, it comes under permutation. Whenever here we'll say selections, right? Whenever I say how many ways you can select three students, how many ways you can select three cards, like that, if you say that, it comes under combination problem. Whenever I say that how many ways it is possible to arrange three from four elements, how many four students can sit in a row, like this, if you say that sitting arrangements means it is comes under permutation, right? This is the one observation you do that. And here it will be more. For example, in the same example, for example, ABCD four elements, and I'm asking you about three three combinations of four. So when I say three combinations of four, for example, here this is one combination A, B, C is one combination. Whereas when I say three permutations of four objects, this single selection ABC will give this single three elements ABC, it will give six elements here, six possibilities. ABC, ABC, sorry, ACB, I'm sorry, ACB, right? Then right, just a minute. Okay. So one combination is giving so many permutations, right? So I'll explain that one. So right, so now what are the possibilities? See, this is one ABC, one selection, but this single selection will produce so many combinations. What are the ABC, ACB, and then BAC, BCA, then CAB, CBA. See, what are all these things? See, only three elements I am using, but arrangements. That means the order is considered. So these are the six possibilities. These are the six permutations or arrangements. Okay. So whereas here this is a selection. So when I say selection, so simply I can say ABC. Whereas when I say permutations, I have to consider their order of their presentation. ABC, ACB, EAC, like that. So in general, so permutations number is more, right, compared to selection number, right? That is also you can understand that. So anyway, we can say, for example, in our class we are having 60 students, right? Suppose in the earlier semester, in the beginning of the semester, we select two students as a CRs, right? So what are the possibilities? See, suppose we'll take 60 members, 60 students. So with the roll numbers 1, 2, 3, 4, 5, 6, and so on, 60. So what are the possible ways or possibilities of selecting two students from 60? So I may select roll number 1, 2 as a CRs, or roll number, right? Say general combination, roll number 3 and some 54 as a CRs, or otherwise roll number 41 and 60 as a CRs. There are so many possibilities, plenty of possibilities, right? Who are the two CRs? Maybe 1, 2, roll number 3, 54, 40, 41, 60. So like that, there are so many possibilities. So these are all selection of two members, selection of two students or two students from 60, right? So these are the possible ways, right? So even if you go for second year, I mean third year, fourth year. So in some particular semester, you'll be having you need to select electives, right? So electives will be there, right? So suppose if you take a total out of 5 subjects, for example, first subject is compulsory, second subject compulsory, right? And the third one is also compulsory, but fourth one, you will have the choice. Suppose in this syllabus they will give A paper, B paper, C paper, and out of 3 you have to select only one. So under fourth subject, like this. Similarly, under fifth subject he will give some options X, Y, Z. So you have to select one, any one, as you are, right? So 1, 2, 3 are compulsory subjects. Under fourth subject you will have 3 options. Under fifth subject you may have again 3 or 4 or 5 subjects will be given. You have to select as one. So that is elective subjects, will say. So like that, right, day to day you will come across so many situations where we need to select. And particularly if you go for shopping, right, selection is a favorite word for you, right? Selecting right, the dress which you like most, right, like that. Now, so again, I told you that whenever we'll discuss about permutation and combinations, what are the permutations, what are the combinations is not important for us, but how many permutations, how many combinations are important, that is important for us, right? So, yeah, here, so the same way. So I have n objects here. I have taken n objects. See here, n objects, okay? And just now I told you what I mean by a combination of n objects or at a time, okay? N objects are taken R at a time. Otherwise, R combinations of n objects. So the number of R combinations of n objects is denoted with the C of n comma R. Number of R combinations from n objects. In other words, number of ways selecting R objects. See, words you try to get it. Number of ways of selecting R objects from n. Selection of R objects from n. Okay. So it is selection. Okay, selection of R, okay, from n, number of ways. Okay, so how many ways? Number of ways, that is the word, number of ways. right? Number of ways of selecting R from N. How many ways you can select R objects from N? How many ways you can do it? So this is denoted with C of N comma R. In other words, NCR. This is the thing, right, man? And the formula for this one is given here, right? Same. So N factorial and by, right, R factorial into N minus R factorial. And recollect this thing, so that is P of n comma r, right? This is permutations P of n comma r, which is actually which is given as a n factorial by n minus r factorial. So obviously denominator is more for these combinations. When denominator is more, total ratio will be less. So combinations will be generally in less in number compared to permutations, right? That is one observation you just recollect it. And one more point I'll tell you. So C of n comma 0, because compared to permutations, combinations are more important in probability. So we'll use more number of examples based on combinations. C of n comma 0 is 1, right? So some calculations purpose, it is easy to remember. C of n comma n, C of 4 comma 4, C of 5 comma 5, it is also 1. So that means suppose we have 4 students, or right, 4 students, you have to select 0 students from 4. How many ways you can select 0 students from 4? One way, right? So right, so this is actually n comma n is okay, right? uh, this is n, sorry, C of n comma 0 is n, okay, and the C of n comma n value is 1, right? So okay, right. So move to the further. So this is 1, and similarly we can also observe that C of n comma r value is same as C of n comma n minus r, right? C of n comma r value is same as C of n comma r, right? So that means when do we use this? So I'll tell you on calculation point of view, easy one. Okay, so that is, I think this is 1 only. I'm sorry to say, this is C of n comma 0 is, so n factorial by 0 factorial is always 1, n minus. So this is 1, I'm sorry. Right. So C of n comma 1 value is, right? Okay, n, I'm sorry. C of n0, C of nn. So both are ones. C of n comma 1. So I'll write here C of n comma 1. How many ways you can select one candidate from n persons, from n persons? So how many ways you can select one means n, right? So anyway, so this is now suppose you want to go for C of right. So 4 comma 2. So select 2 from 4 means generally what we'll do. So 4 factorial will do, and 2 factorial, again 4 minus 2 means 2 factorial, right? So 4 factorial 24, or otherwise 4, 3, 2 factorial, right? And 2 into 2 factorial, or 2 factorial, 2 factorial. So these two get cancelled, 2 2s. So these 6. So selection of right, 2 from 4. How many ways you can select 2 candidates from 4 means 6 ways, right? Like this we can do it. And suppose if you, instead of, you don't want to calculate, suppose we have very big number. Suppose I have 7 comma 3, right? You need to go for 7 comma 3 or 7 comma 2. So 7 factorial I have to write, below you have to write 5 factorial, like that. So shortcut of this one is, instead of doing this, you can simply write, so 7 you can write it as 7 into 6, only 2 numbers you write, right? Because it is 2 numbers, 7 into 6. Here also you write 2 into 1. So this is, so 21, right? So 2 3s, right? So this is 21. So C of 7 comma 2, you can write it. That means 2 numbers. This is 2 means, so decrease the presentation of 7 with 2 terms, 7 into 6, and the 2 is there, 2 into 1. So, and then simplify. This is 2. So this is one way of doing. So right. So this is the number of ways of selecting R objects from n. Right. This is one formula. And the calculation point of view, you can remember a few. And this is one technique, right, in calculations. Right. Now, so in probability, again, we always come across with some examples of tossing coin, right? Always we know that tossing a coin, and right? So what happens when I will toss a coin? There are two possibilities of getting heads and tails. Okay, so recollect that. So what are the possible outcomes when you toss a coin? Heads and tails. Similarly, we'll come across with the example. So many times we'll get it. So tossing a die or rolling a die. So when you roll a die, right? Die is a cube, right? It is having 6 faces. On each face, you will be right. We are it is appearing one dot, two dots like that, three. Okay, so 4, 5, 6. Now we are able to see here we have 6. This is 4. This is 5. Right. On other three more sides, you will be finding 2, 1, 2, 3. So what are the possible results when you toss a die or roll a die? It is 1, 2, 3, or 4, 5, 6. And one more important example, which general will come out, cards. Okay, so if you just check this example of cards, so there are totally 52 cards. This description you are supposed to know. Okay, so 52, totally 52 cards are there, out of which, okay, so 26 black and 26 red. Okay, so you just recollect it, 26 black, 26 red. Okay, and the 26 black again splitted into two combinations, that is 13, right? So this is the first one. You can see that this symbol, okay, or this is the symbol. You can check this one. Okay, these are called clubs and these are called spades. Okay, so 13 clubs and 13 spades. Similarly, when you check 26 red, they are also divided into two sets. So 13 hearts and 13 diamonds. Okay, so 13 hearts and 13 diamonds. Okay, and each 13, 13, 13, 13. So all these 13 cards are consisting of one ace card. You can see here one ace card, right? After that 2, 3, 4, 5, 6, 10, and we say, and face cards will say face card, right? Jockey, queen, and king. J, Q, K. Order also you remember, J, Q, K. In place of 11, 12, 13, right? We say J, Q, K, right? So A's, starting one A, that is just like 1. After that 2, 3, 4, 5, 6, 10, like that. Okay, so make a note of this one. Suppose if I say how many A's cards are there in a pack of 52? This is total pack, a big pack of 52, right? So how many A's cards? A's cards means 1, 2, 3, 4. One A's card with club symbol, one A's card with spade, one with heart, one with diamond. Similarly, how many face cards are there? How many jockey cards are there? Jockey again 4. How many queen? 4. How many king? 4. But suppose if you say in example, how many face cards? Face cards means, so totally we'll have 12. Numbered cards, we will say, numbered cards. Numbered cards we can count. So like that you can see the description, right? So make a note of this, that 52, 26 black, 26 red, and in 26 black, 13 clubs, 13 spades, in 26 red, 13 right hard cards, and 13 diamonds, right? So this is also one description you try to recollect. Okay, and now see, we'll just go for some examples in the combinations. So remember, combinations means selection. It is simply selection. Okay, or otherwise we can say it is a subset of elements, right? So now, in how many ways can a committee consisting of 3 men and 2 women can be chosen from 7 men and 5 women, right? I think there are maybe some particular committee we have to choose. So there are 7 men, right, are there, and 5 women are there. So they want to form a committee. Okay, but that committee should consist, right, 3 men from 7. 3 men should be there in that committee. So it is a 5-member committee. Okay, so and 2 women should be there from 5, right? This so totally how many we should require? So totally 5. So a condition that 5-member committee we have to select from 12. There are totally 12. From these 12, okay, we have to select 5, but condition is out of these 5, 3 men should be there, 2 women should be there. So just now I told you that how many ways, recollect that how many ways I can select R from N objects. R objects from N. How many ways you can select? C of N comma R. Now coming to this point of view, right? So how many ways I can select 3 from 7? So I can 3 from 7, I have to select 3 men from 7. So how many ways I can do? This is C of 7 comma 3 ways. Similarly, how many ways you can select 2 from 5? So 2 from 5 I can select in C of 5 comma 2 ways. Now what I have to do, try to recollect one point. So okay, three women from 7 I can select in C of 7 comma 3 number of ways. 2 women from 5 can be selected in C of 5 comma 2 ways. And now what I have to add, what I have to do these two numbers. So whether I have to add or I have to multiply. So what is the thing? So total how many ways are there? So I have to, because condition is 3 men and see that word and. So whenever we say and, so we need to multiply the results. So this is called the product rule. C of 7 comma 3 base into C of 5 comma 2. So the two results are two numbers. Whatever you will get, the two numbers you can calculate, and the two numbers should be multiplied. So you may have the doubt. So when to multiply, when to add. Whenever you recollect that product rule says that, when I think earlier I told you, okay. So whenever we have and, so we need to multiply. Whenever we say are, okay. So we had to add. We had to add. Okay. So recollect these two things which are useful. Okay, right? Sorry, which are useful. Okay. So and means multiplication, or means addition. So that is one thing you can do. So 3 men and 2 women, 3 men and 2 women, and so and making us to go for multiplication. So take this product, right? So let us discuss the next one. So a student is to answer 8 out of 10 questions in examination. Say for example, we have 10 questions, just like you people will write the right. So here they have simple way of this one. So 10 questions are given. So they have to attempt 8 questions in that examination. They have to attempt 8 questions. That is the thing. But he is giving different conditions. Under different conditions, we have to find the answer. Now, generally, how many ways he can attempt? A student is okay. Let me go for the first one. How many choices has he? So 8 questions. 1, 2, 3, 4, 5, 6, 10. He has to attempt 8 questions. Any 8. He may go for 1 to 8, or he may go for right. So third, fourth, fifth, leaving the first two. Like that, any 2 questions he can leave. Remaining 8 he can write. How many ways are there to attempt this question paper? Okay, so how many choices he's having? Simple. So he has to select 8 from 10. So how many ways he can select 8 from 10? C of 8, 10 comma 8 ways. C of 10 comma 8 ways. The calculation you can do that, right? I told you the shortcut just now. C 10 into, yeah, C of 10 comma 8. See, don't write. See, this is one more. 10, I told you just now, 8 times you write that, 10, 9, like that. But instead of that, you can use another one. Okay. Just a minute. Right. So what is the another way of writing this? Just now I told you that C of 10 comma 8 is the same as C of 10 comma 10 minus 8. 10 minus 8 means 2. Right? 10 minus 8 is 2. So remember 10 comma 8 value, C of 10 comma 2 value same. And it is now easy. So 10 you write it, reduce it to 2 times. 10, 9, 2, 1. So simply, so this is 45. Right? So remember, this is one way where it is going to be very much helpful when you are discussing about this. Okay, so make a note of that. Right. Yeah. So that is 45 ways. So this is one observation you can do. Now, what about right? The second one, right? Second condition, what is giving is how many ways he can attempt 8 questions out of 10. But condition is he must answer the first 3 questions. Okay. So what he's saying, out of these 1, 2, 3, 4, right? Like this, we have 10. So in the first bit, he said that any 8 questions he can do. That is 45 ways he can do that. But in the second condition, he's saying that first 3 questions he must attempt. He has no choice. First 3 he has to attempt. Okay. So and how many are left over? 5. So from 3, right? If these 3 is compulsory, and from the remaining 7, so remaining 7 more, and from this 7 he has to select any 5. So he has to attempt 1, 2, 3 compulsory. Okay. Anyway, he's attempting. Now the choice is from these 7. So from these 7 questions, he has to attempt remaining 5. Okay. So how many ways you can do now? So 3 questions, how many ways you can attempt? 1 way. It is compulsory. There is no choice there. And what is the leftover thing? So he has to attempt to 5 questions from 7. That can be done in a sea of 7 comma 5 ways. So little bit logical. And remember, from your coding in placement examinations, these combinations play a very important role, right? So calculation point of view, what is the meaning of this, right? You are having one more paper, we'll be discussing discrete mathematics in next semester. So in that semester, you will be discussing combinations, permutations in deep, okay? So many other further cases we'll be discussing. So it is quite useful, okay? Right. And now what is the third one? So how many, if he must answer at least 4 of the first 5 questions. Now see, 5 questions, now totally first to 5 means 1, 2, 3, 4, 5, right? And then remaining 5 questions, 6, 7, 8, 9, 10. Say for example, 10, totally 10 questions. Let us, according to this bit, we'll divide total 10 into 2 parts. First to 5, last to 5. First to 5, last to 5. Now condition what he's seeing, at least 4 of the first 5 questions. He has to attempt 4 questions, at least 4. Remember the word at least, right? If you say only 4, it is different, right? So he's saying at least 4 from first 5 questions. So that means from this first 5, he has to select at least 5. Minimum 5 he has to write, okay? So either 5 he can write, or he can also write 5. 4 or 5, sorry. He has to write minimum 4 or 5. Suppose if you write 4 here, and how many he has to attempt from here? So he has to attempt again 4. 4 plus 4, 8, right? Suppose he has attempted one more possibility. One more possibility. Suppose he attempts 5 questions from this first 5. Now it is enough to, if he go for only 3. Now these are the possibilities. So at least 4 means either 4 from 5, 4 from bottom, and 5 from first to 5, 3 from last to 5. These are the two choices. Either 4 plus 4 or 5 plus 3. How many ways you can do this one? Right? First to 4, C of 5 comma 4 into C of 5 comma 4. This is the first choice. So 4 questions from first to 5, 4 questions from bottom 5. This many ways you can do, right? So C of 5 comma 4 is nothing but 5. This is 5 into 5. Okay, calculation part you can do. And the second one, how many ways you can do? So C of 5 comma 5 plus, sorry, into C of 5 comma 3. This many ways you can do it. And this is 4 4 combination number. This is 5 and 3 combination number. But what we have to do, both these two number, this number and this number. Okay. So what we need to do? So this is actually the number 5 into 5. This is 25. 5 into 5. Say 25. And this number is C of 5 comma 5. C of 5 comma 0 value is 1. C of 5 comma 3 is I think it is 10. Okay, 10. Check that, 10. Okay, so what we have to do, 25, 10. What I have to do, whether I have to multiply these two or I have to add. And see here, it is R. So either this choice or this choice. This choice will give you 25 possibilities. This choice will give you 10 possibilities. So what I had to do, I had to add. Okay, so total number is 25 plus 10. 25 plus 35. Okay, so just concentrate on this once again. Just go through carefully. So this is the last combination. Now, so just card problems. Okay, so 2 cards are there. 2 cards are drawn at random from a pack of 52 cards, right? So find the number of ways where both are spades. Okay, now generally 52 cards are there. You have to select 2 cards. How many ways are there? How many ways are there? So simple. C of 52 comma 2. C of 52 comma 2, which is 52 into 51 by 2 into 1. Okay, I cannot calculate, you do it. No, this is generally, no condition. Just 2 cards you have to select from 52. How many ways you can select? So this is the number of ways. But he's giving one condition here. Those 2 cards must be spades, right? Spades symbol, right? So how many ways you can recollect that, right? These are the spade symbols, right? Spade, this one, okay, symbol, recollect it. So how many spades cards are there? So obviously spade cards are 13. So indirectly he's saying he needs 2 cards which are spades. So how many ways he can select? C of 13 comma 2 number of ways he can select, because only 2 spades he wants, right? So 13 only I need to consider, remaining I don't want, right? Hearts, red cards, that in diamond cards, he doesn't want that. He wants only spades. And similarly, second one, what it says? So second one says he wants 2, but condition is one spade and one heart, right? So one spade and one heart. So, right, so one spade card from 13 can be selected in a sea of 13 comma 1 ways, and one heart card can be selected from 13 because heart cards are also 13. So sea of 13 comma 1 ways. And then what I had, this is nothing but recollect that this is the selection of 1 means 13 only you will get. Here also 13, sea of 13 comma 1 is 13. Again, what is the observation? I had to add them or I have to multiply these two. So you recollect, you just check that I want one spade and, right, by product rule, and is there means we have to take the product. And so 13 into 13, maybe 169. Okay, so that is, so like this. Okay, so just we'll need to practice few more varieties so that you can get the clarity. Now let us see that one more. A class consisting of 9 boys and 3 girls. So in a class there are say 9 boys and 3 girls. Okay. So in our class we do not have that choice. Okay. No boys, right? Right. So anyway, so first problem. What is the first problem he's saying? So in how many ways can teacher choose a committee of 4? Okay. So yeah. So totally how many students we have? Totally 12 students. So total 12 students are there, right? Irrespective of boys and girls, 12. And first condition is saying that he wants to choose a committee of 4. So he's not mentioning that out of 4, how many boys, how many girls. He wants 4, any 4 may be boys, 4 may be girls, or 2 boys, 2 girls, 1 boy, 3 girls, any combination. So he has to select 4 from 12, right? So how many ways you can do? Obviously, C of 12 comma 4 ways. So that is the first question, right? So in the first question, so right, so no need of thinking about boys and girls. So 12 out of 12, you have to select 4. This many ways you can do. But second question says, yeah, see here, how many of them will contain at least one girl? So at least one girl should be there. Yeah, see now choice. Say I have girls and boys, 2 possibilities. So one girl must be there in the committee. So that is the condition. Okay, because girls are having more patience or due to some plus points. So girl must be included. So what are the possibilities? Totally I want 4, but minimum one girl should be there. So one girl, right? Or otherwise 2 girls, or maybe 3 girls, or maybe 4 girls also. This is the condition. Minimum one girl. At least means minimum. Minimum one should be there. So when one girl is included from 4, boy should be taken 3. Here 2. Suppose 3 girls are there in the committee means choice one boy we are having, he is having the choice, and here 0. No boys. Yes, yes, we can select all 4 girls. This is one. And how many ways you can select one girl from 3? One girl from 3 girls. Totally recollect that 3 girls are there and 9 boys, right? So how many ways we can do this? We can do C of 3 comma 1 way. Okay, and means multiplication, C of 9 comma 3. So this is the possibility of one girl from 3 and 3 boys from 9. This is one possibility. Similarly, this is the C of 3 comma 2, C of 9 comma 2, and this is a C of 3 comma 3, right? Okay, so sorry, that C of 9 comma 1. Sorry, so this is not possible because I forgot that there are 3 girls only. So I cannot select 4, sorry, right? So only possibility is this one, right, ma? Yeah. So, right, these are the 3 possibilities, right? So this is a C of 3 comma 1, this answer, right? And here, these are the possibilities. C is 1, 3, 2, 2, 3, 1. There are 3 options, 3 possibility ways are there. So finally, what we'll do, we'll just add these answers. Okay, we'll get the answer, right? So where we are applying addition, where we are applying multiplication. Whenever we say and, one girl and 3 boys, so multiply, right? Similarly, 2 girls and 2 boys, multiply, and we have multiply. And these are the 3 choices: first choice, second choice, third choice. So the choice means R. So add them, plus, 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 right? This is the second bit. And now what about the third one, right? Third one is how many of them will contain exactly one girl. Obviously, exactly one girl out of 4 means only first bit. C of 3 comma 1 plus C of 9 comma 3. Okay, C of 3 comma 1, C of plus 9 comma 3. Exactly one girl. Okay, committee, one girl. That means remaining must be boys. This is the answer. Okay. Right. Now, so with these examples, you can discuss. Now, let us go for one more concept. In probability, we use, now and then we need to draw for our convenience, right? We'll do this tree diagrams. So what is by tree diagram? It is a divide used to enumerate all possible outcomes of a sequence of experiments where each experiments can occur a finite number of ways. So experiments will do. Experiments means which produces some results. We'll discuss about that correct terminology later. So when you do 2-3 experiments sequence, first experiment, second experiment, now how to draw? Suppose if I say, if I toss a coin, right? What are the possible outcomes? Head, comma, tails, for example, and then roll a die. So die, you take it and roll it. When you roll it, what are the possibilities? 1, 2, 3, 4, 5, 6. Right now, suppose I'll do the sequence of experiment. First, I'll toss a coin and then I roll a die. Now, what are the possible outcomes? Okay, sequence means doing 2, 3 or more than one experiment one by one. Okay, now first I'll toss a coin, then I roll a die. Now I want to know what are the possible. So this can be constructed, okay, with a tree diagram. So when you toss a coin, what you are going to get? First experiment I'm doing. When I toss a coin, right, I'm going to get either head or tails. Okay, and once you, this is first experiment. When you do the second experiment, now what are the possibilities? So I may get 1, right, 2, similarly 3, 4, 5, 6. Similarly here also, right, 1, 2, 3, 4, 5, 6. 1, 2, 3, 1, 2, 3, 4, 5, 6, like this. Okay. Now, see, this is easy way, right, without confusion. So first experiment will give two outcomes, head, comma, tails, and after that second experiment, right, it will give 6. Now, based on this, you can write easily what are the possible outcomes. So first one, this is one possibility. When I toss a coin, first I may get head, and the second experiment I may get 1, h comma 1. This is one possibility. Similarly, h comma 2. First coin head, number is 2. Like that, h comma 2, h comma 3, h comma 4, h comma 6. Similarly, here you will give another possibility, t comma 1, t comma 2, t comma 3, like that. So, t comma 1, right, t comma 2. So, to understand what are the possibilities, how to write the possibilities, this is way how you can check, right? So, sequence of experiments. So, just the tree diagram will help us to how to just write the outcomes. Okay. So, how many outcomes are there means it is simple. So, when you toss a coin, you will be getting, right, two outcomes, say for example, and when you roll a die, these 6. Okay. So, 6 ways you'll get. And I am saying and, right. So, this is totally 12 ways. What are the 12 ways? How? What are them? What are the 12 ways means? You can write that structure, tree structure will say like that, so that right, it will be helpful for you to have an idea what the possible. So in particularly when you go for right, conditional probability, so there we use this structure. So just I am explaining. It is very simple thing. Okay. So with this tree diagram, so we'll end the session. Okay. So with this basic introduction to right, so combinatorics. So anyway, I have just defined basics, right? So combinations means it is not what the things what I explained here. There are so many other further things, but we don't use much in probability. I told you earlier that just now, we're having a discrete mathematics. Okay, in some colleges or some universities, they also mathematical foundations of computer science. That is a paper purely mathematical, computer oriented mathematics. You will discuss in that discrete mathematics paper. Okay, so there I think you have this topic of combinatorics. So how many ways you can do like that, right? So that will be right helpful there to discuss more in the depth. But meanwhile, with these information of combinations, you can maintain our probability. Okay, so we'll end the session here. So see you in the next session, right?